Understand the goal of gravimetric analysis. The primary objective of gravimetric analysis is to determine the amount or percent mass of a target analyte, in this case, silver, Ag to the power plus, by converting it into a solid precipitate of known chemical composition that can be physically isolated, dried, and weighed. Identify the species present in the mixture. Dissolving the jewelry alloy in nitric acid, HNO3, yields a homogeneous liquid mixture containing dissolved Ag to the power plus and Cu to the power 2 plus ions. Because both metals are dissolved, they cannot be physically separated in their current state. Determine the method of chemical separation. To isolate the silver from the copper, you must perform a selective precipitation. This requires introducing a specific precipitating reagent, an ion, that reacts to form an insoluble solid with only one of the metal ions, while leaving the other metal ion dissolved in the aqueous solution. Identify a suitable chemical reagent. For instance, adding a source of chloride ions, such as NaCl or HCl, introduces Cl to the power negative ions into the mixture. Because AgCl is highly insoluble, Ksp equals 1.8 times 10 to the power minus 10, and CuCl2 is highly soluble. The chloride selectively precipitates the silver ions as solid silver chloride. Ag to the power plus plus Cl to the power negative gives AgCl. Formulate the next analytical step. By adding in an ion that selectively precipitates only one of the metal ions, the student can then easily filter out the solid AgCl precipitate, wash it, dry it, and weigh it to calculate the original silver content of the jewelry. This corresponds to option D. The correct answer is option D, adding a solution containing an ion that forms an insoluble salt with only one of the metal ions.